Unit 2.1, we do practice. Classify each bond and indicate any full or partial charges. So the first thing we have to do when identifying bonds is we have to identify the atoms or the elements involved in the bond. So below we have sodium, which is a metal, and then we have chlorine, which is a nonmetal. So when we have a metal and a nonmetal bonding, we know that's going to form an ionic bond. So there's our first part. We've classified the bond, so it's an ionic bond, and now we need to indicate any full or partial charges. Since this is an ionic bond, we're actually going to have full charges because we have a transfer of electrons, and we're going to have an electron transferred from our sodium to our chlorine, and that's going to give us a full positive 1 charge, or a 1 plus charge over our sodium. And then because that electron is being transferred to chlorine, that's going to give our chlorine a 1 minus. So for this compound, because I have a metal bonded with a nonmetal, I'm going to have an ionic bond, and I'm going to have a full 1 plus charge on sodium and a full 1 minus charge on chlorine. So for this next compound, we have carbon bonded to oxygen. So the very first thing we have to do is identify what kind of elements these are. So carbon and oxygen are both nonmetals, so we know this is a covalent bond. But we got to be a little more specific with our covalent bonds because they can either be polar or nonpolar. So to determine whether or not this is a polar or nonpolar covalent bond, we have to look at the electronegativities of the elements. So oxygen is actually further to the right, closer to fluorine than carbon. So oxygen is going to be our more electronegative element here. So that means it's going to have a stronger pull or a stronger attractive force on the shared electrons within this bond. So that means that our carbon and oxygen are going to have partial charges, and our oxygen is actually going to have a partial negative charge, right, because it's going to be hogging those electrons within the bond. And carbon is going to have a slightly positive charge because the electrons aren't hanging out near carbon quite as often. So our carbon is going to be partially positive, and our oxygen is going to be partially negative. So remember the two ways we can denote this. The first way is with our dipole arrow, where we have a positive over our more positive element, and then we write an arrow, draw an arrow pointing towards the more electronegative or the partially negative element. So this would be how we draw a dipole arrow for this compound, indicating that carbon is partially positive and oxygen is partially negative. The other way that we can do this is with our lowercase deltas, and we're going to have a lowercase delta negative for our oxygen and a lowercase delta positive for our carbon. So our next compound is a bond between cesium and fluorine. Notice we did skip C, magnesium and hydrogen, because that one's a little trickier and beyond the scope of what we need to know right now. So we're going to skip that one and focus on cesium and fluorine. So again, I have a nonmetal and a metal. So fluorine are nonmetal, cesium are metal. So it's going to be an ionic bond with cesium taking on a 1 plus and fluorine taking on a 1 minus. And those are going to be full charges, again, because it's an ionic compound. Next, I have a bond between two bromines, and bromine is a nonmetal, and this is a diatomic or a Brinkelhoff. So this bond is going to be a covalent bond. And because our elements are both the same, that means we have to have equal sharing of electrons. So this is going to be a nonpolar covalent bond because there's an equal sharing of electrons between our two nonmetals. And since this is a nonpolar covalent bond, there aren't going to be any full or partial charges on either of my bromines. And finally, I have sulfur double bonded to oxygen. The fact that this is a double bond won't influence the type of bond that we had. It's just an additional categorization that we can make. This is still going to be, because I have two nonmetals, both of these bonds are still going to be covalent bonds. So now I have to determine whether those bonds are polar covalent or nonpolar covalent. And since sulfur and oxygen have different electronegativities, it's going to be a polar covalent bond. So now I need to look at my electronegativities, and on my periodic table I can see that oxygen has a higher electronegativity than sulfur, so it's going to be the slightly negative one, and sulfur is going to be the slightly positive one. And I can represent this with my dipole arrow like so, or with my lowercase deltas like so.